All right, this is number 1 on our classwork for today. Since I am absent, I'm going to be doing it on this video. I'm just going to rewrite this whole thing. Oh, wow. I'm going to rewrite it down over here in factored form. So I can see that there's a common factor of 5 here. So I'm going to take out the 5. I'm left with x minus 7y. I'm going to go to the bottom of that fraction here. There's nothing I can see that factors there. I'm just going to continue on to the other fraction over here. Again, I don't see anything I can factor out there either, so I'm just going to rewrite those as they are. This, however, is a difference of squares. Perfect square, so I can write it as the square roots added and subtracted. X minus 7y and x plus 7y. And now I can see that x minus 7y and x minus 7y will reduce, and what I have left is the answer. So it's just going to be 5 times x plus 8y over x plus 10y times x plus 7y. There it is. Number 2. We are doing pretty much the same thing, but you can see I have in the division symbol there, which means I'm going to have to flip this upside down. Always keep the first one the same, but flip the second one upside down. So let me rewrite it with the second fraction flipped. X to the 5th y over 10y to the 5th. And whenever I flip it, I'm going to actually change to multiplication. That's the rule. When you're dividing, you multiply by the reciprocal, or the flipped version of the fraction. I've got 3x to the 4th over 4y. Now I'm just going to go ahead and cancel out common terms. I see a y over a y. So that means I'm going to have 5 y's on the bottom. And x to the 5th times x to the 4th. Hopefully you remember your rules of exponents. When I'm multiplying the same exponent, I'm going to add the 5 and the 4 to make x to the 9th. So I got 3x to the 9th all over. I've got 10 times 4 is 40, y to the 5th. This is a 9. There we go. That's it for number 2. A lot of the same idea, just mostly simplifying the rationals. Okay, we are going to try that again. I said to flip that fraction, but I didn't flip it. I just rewrote it as it was. So let me flip the fraction. Actually do what I say I'm going to do. There we go. We're going to be multiplying, of course. X to the 5th y over 10y to the 5th. Now we've got some more stuff that cancels out. Thank goodness. Okay, so the x to the 5 over the x to the 4, that's going to become nothing. This is going to be x to the 1. I've got 2 y's on top, so 1y, 2y. So that is going to go down to the power of 3. And this will reduce to 2 over 5. 4/10 reduced to 4. 4/5 reduced to 10 over 2 over 5. Yeah. So I've got 1x on top and a 2, so 2x over 5 times 3 is 15. 15y to the 3rd. That's better. Okay, in this one, I'm going to do the same thing. I've got to flip this fraction upside down, and I'm just going to reduce a lot of the same stuff over and over again. 2x minus 6. Oop, I see I can factor that. That is going to be 2 times x minus 3. So I'm going to factor that first. This bottom part of our initial fraction can be reduced, or factored to 3 times x plus 9. And then, of course, I flip this one upside down to get x plus 9 over x minus 3. And it's being multiplied now that I flipped the fraction. Division means multiplying by the reciprocal. So that reduces, this reduces, we get our answer of 2/3. Another problem with a very similar situation, I'm going to write the first fraction down, keep it, and I can see that I can factor out a 3 on top there. That would be x plus 3 On the bottom, I've got a trinomial. Hopefully you're getting better at factoring trinomials. I see this is 2 times 3, and it's got to be a negative 3 because that's adds up to a negative 1 in the middle. So x minus 3 times x plus 2. Just really double check to make sure that's right. X squared, then minus x, and then minus 6. Yeah. Okay, we're going to be multiplying by the reciprocal here, so I'm going to factor this one. This one is x minus 2 times x minus 3. It's going on top now because I'm dividing or multiplying by the reciprocal. X minus 2, x minus 3. That adds up to negative 5, multiplies to 6. And then on the bottom, I've got another x plus 3. X plus 3. So let's see what we can reduce. We've got x plus 3 over x plus 3. We've got x minus 3 over x minus 3. And this is a minus 2, and this is a plus 2. So that does not reduce. They have to be exactly the same. So this is going to be 3 times x minus 2 over x plus 2. Okay, another one here. I'm going to factor the top. Some of you may like to do the method where you multiply the first and the last. I am more of a guesser and checker. I just think it saves time, so I do it that way. But let me rewrite it. I know it's going to be 7x for one of the first terms, and x there, that's the only way you can get 7x squared. And then 8 could be broken into 2 times 4 or 8 times 1. And I know the middle has to be negative, so I'm thinking 7 times 2 plus 4, or minus 4. 7 times 2 minus 4. That looks right. That'd be 7x squared minus 14x minus 4x, and then plus 8. On the bottom, I've got an x plus 6, and I'm going to be multiplying by the reciprocal here. This is going to be 3x plus 10 on top. And then on bottom there, I've got 2 times x minus 2. I can see that the x minus 2's are going to cancel out. And that's about it. I do not see anything else. Bummer. Okay, let's just go with that. Got 7x minus 4 times 3x plus 10 all over 2 times x plus 6. And another one here. I'm going to factor the top here. It looks like the two factors of 12 that add up to 4 would be 6 and 2. It would be a plus 6y, that is, and x minus 2y. And then on bottom, just an x plus 9y. I'm going to multiply by, you guessed it, the reciprocal. X minus y is now on top. I'm going to factor out a 5. And I should get x plus 6y. I do. And I can see that x plus 6y is a common factor. X plus 6y, x plus 6y. Again, I don't see anything else that factors out, or excuse me, simplifies, so the answer is everything left over. X minus 2y and x minus y all over 5 times x plus 9y. This one's a little bit longer, but it's the same idea. Order of operations says we have to do the multiplication first. Well, they're both on the same level of priority, multiplication and division, so you just go left to right. Start off with this first one here. I've got the 7x on top, and I'm going to factor the bottom. It looks like 3 times 5, so x plus 3 times x plus 5. And then I'm going to factor this next one. That's a perfect square, so it's going to be x minus 5 times x plus 5. And then on the bottom of that, I can factor out an x, multiply that times x minus 2. Now we're multiplying by the reciprocal, so x plus 3 goes on top, x minus 5 goes on bottom. The x plus 5 cancels out, the x plus 3 cancels out, and an x plus 5 also cancels out. Good. So we end up with just a 7x on top and then an x times x minus 2 on the bottom. You can multiply that back together, you just don't have to. I lied, there's still one more thing to simplify. The x over x. Oops. Finding the least common multiple, just like it sounds. The smallest number, least, that is a common multiple. So if I'm counting by 4s, what's the lowest number that will land on a multiple of 10? You might think 40, but that's not the lowest. It's actually 20. So 20, and you can write this out. You can write 4, 8, 12, 16, 20, and write out your factors of 10, 20, 30, and you notice, oh, look, 20, that's the lowest number that they land on, the same. Hopefully your number sense is pretty solid and you can come up with those a little bit faster though. As far as the b's, we're just going to do the lowest, basically the highest one is your maximum, because I can multiply by another b, it's going to land on b cubed. So b cubed is the lowest common multiple of the variable. I just take the numbers and the variables separately. Numbers, do those like this. Variables are pretty straightforward here. You're just looking for basically the limiting factor, which is the highest of that particular variable. All right, now we're finding the least common denominator, which is very similar thing, looking for the lowest common multiple of both these two denominators. I'm going to factor them so I can see them a little bit better. So I've got 3 times x minus 4, and over here I've got 2 times x minus 4. So they both have the x minus 4. That's common. We just need to find the lowest common multiple of 3 and 2, which 6. That's the lowest one. You can always find the common multiple by multiplying the two numbers, but to find the least one, sometimes you have to go lower than that. But for this, the answer is going to be 6 times x minus 4. They both had x minus 4 in common. The least common multiple of 3 and 2 is 6. Okay, least common multiple again. I'm going to factor them first to see if they have any common factors right now. 2 factors of 14, 7 and 2. So minus 7 and x plus 2. Double check to make sure that is right. Minus 5x minus 4. Yep. Here, this is a difference of squares. So I've got x plus 4 and x minus 4. There is nothing in common here. If that happens with these binomials, with these polynomials here, you're basically just going to multiply them both together for your common multiple. So I'm going to add a x plus 4 times x minus 4 over here, and on this side I'm going to add an x minus 7 and an x plus 2. You can multiply all those out if you want. It is not necessary as far as I'm concerned on this problem. So common denominator, or the least common denominator, is going to be basically all the factors. I could have written them just like this times this too. Either way, it should work. All right, on this problem, they're telling us what our change in denominator is. So if you look at what's happening here, I'm going from 4y to 4y to the 5th. Well, what did I multiply by? I must have multiplied by y to the 4th, because that would make it 4y to the 5th. So that means I just have to do the same thing on top, multiply by y to the 4th. So you can see I'll end up with negative 5 times y to the 4th. Same situation here on this problem. What did I multiply the bottom by? I multiplied by a negative 1. That would distribute to both of those, make them both negative. So I'm going to multiply the top by negative 1. Negative times a negative is a positive. So just get 8 there. That's the answer. Positive 8. Okay, we're to a full-fledged addition problem. We're going to be adding 2 rationals, or basically fancy fractions. These have exactly the same denominator, so it's not going to be real difficult. If the denominators are the same, just add the numerators and keep the denominator. So 2 plus z, why that is 2 plus z. And we just put it under one denominator instead of two. And we're done. Hopefully that's pretty straightforward. Next problem here is very, very similar. We have the same denominator, so we're just going to go ahead and subtract the tops. 13x minus 7x, we can combine those. They are like terms, so that would be 6x. The 3 doesn't get bothered, and we're all over 9x. Now, it does say simplify your answer as much as possible, and I see that there is a common factor, not just between 6 and 9. If it was just between 6 and 9, I wouldn't be able to do that. It has to be a common factor from everything on top and everything on bottom. That can be confusing at times, but never reduce just part of a rational. You have to do the whole thing. So in other words, I'm going to factor the top. I see that I can factor out a 3, and I get 2x plus 1. And then on the bottom, I also have a factor of 3, and that would leave me with 3x. And I'm going to simplify 3 divided by 3, anything divided by itself is 1. That x cannot be simplified. The x would have to be a part of the second term in this polynomial. In other words, it would have to be a part of the entire numerator. You cannot just simplify the parts you want. It does not work. So my final answer is going to be 2x plus 1 over 3x. All right, last one, and looks like for the first time we do not have a common denominator. One easy way to always find a common denominator is just to multiply the numbers. That won't always give you the least common multiple, but it will give you a common multiple. In this case, it does happen to be the least common multiple as well. So I'm going to multiply this one times 4 over 4, multiply this one times 3x over 3x, and I'm going to get 3x times 5 is 15x over 12x minus 28 over 12x. Now that I have the common denominators here, I can just do the operation with the numerators. 15x minus 28. They are not like terms, so I'm just going to write it 15x minus 28 all over 12x. Is there a common factor here? It looks like there might be, and it's close. If 28 had a factor of 3 in it, then there would be a common factor of 3, but there is no common factor here. It's close. It might look like it, but there is no common factor. And remember, I cannot reduce or simplify x over x, because that's only part of the numerator. It has to be the entire polynomial. It has to be a common factor of the entire polynomial. That is. All right, let me know if you guys have any questions.